we discuss the topic volumetric methods of chemical analysis. Then what is volumetric analysis? The volumetric method of your chemical analysis is a quantitative chemical analysis. It is a quantitative method in which your amount of substance is determined by measurement of your volume of that substance that occupies here. So in this method, there is a use that is used to determine your unknown concentration of your known reactants here. And volumetric analysis, that is also called as a titration method here. It is a laboratory technique in which one substance of known concentration and volume that will be used to react with your another substance of your unknown concentration. Now, definition of your some terms involved into that your volumetric analysis here. So volumetric analysis involves your preparations, storage, and your measurement of your volume of your chemicals for your analysis here. Then volumetric analysis is called as also titrometric analysis or titrimetry. And this is your quantitative chemical analysis which determines your volume of your standard solution. Means having your accurately known concentration that will be react with your the titrant or your analyte. The analyte means your whose concentration is to be determined here. And the volume of titrant required to just completely react with your analyte, that is called as a titer also here. Now, what is titration? The titration is a process in which a standard reagent, means a titrant, is added into your solution of your analyte until the reaction between the two is complete. Now, primary standard. What is primary standard? A reagent or solution of accurately known concentration is called as your standard solution. Now, during volumetric analysis, there is a standardization method will be there. Then what is standardization? A process to determine concentration of a solution of your known concentration by titrating with your primary standard. Now, what is the end point? During volumetric analysis, there is a one of the point that will be end point. The point at which a reaction is observed to be completed is called as your end point of titration. And the end point in volumetric analysis is the signal that tells us or that tells analyst to stop adding the reagent and note the final reading on the burette. Now end point is observed with the help of your indicator. With the help of indicator, that means end point that will be observed here. Now next there is a next term that is an equivalence point or equivalent point here. The point at which your equivalent or your stoichiometric amount of titrant is added to your titrant or your analyte, and say that will be based on your stoichiometric equation. Now the equipment that will be used in case of your volumetric analysis that involves here, say number one, that is pipette. Say for measurement of your accurate and your precise volume of your solution, pipette they are used here. Now burette, the burette that will be used here for pouring of your measured volume of your solution here. Means a standard solution that will be taken in burette here. Now conical flask, say for your mixing of your the two solutions, means titrant and your titrant together, that means in the conical flask here. Now wash bottles, say these contain distilled water for your cleaning of your equipments here. Now funnel that will be used for your transfer of liquids without spilling. Now volumetric flask here. So volumetric flask is used to make up your accurate volumes for your solution of your exactly known concentration here. Now the requirement for a successful volumetric titration. The reaction must be stoichiometric. Well-defined reaction between titrant and your analyte. Reaction should be rapid. Reaction should have no side reaction, no interference from your other foreign substances here. Then this volumetric titration must have here some indication of your end of reaction here, such as your color change, sudden increase in pH, zero conductivity, so whatever your physical change that must be observable here, etc. Then known relationship between your end point and your equivalence point here. Say now we see here that is definition of here, that is some term that is a concentration. Say it is a general term for your expressing here the amount of solute that will be contained in a given material, and that will be expressed in different ways here. Into that your first way, that is your molarity. Say molarity is a number of moles of your solute divided by your number of liters of your solution containing the solute. Means here that is the gram molecular weight dissolved in 1 liter of solution means that is called as a 1 molar solution here. Now molarity that will be defined in a simple way, that is number of moles of solute per volume of liters here, as well as your millimoles of your solute per your volume in milliliters here. Then what is the moles? How these moles will be calculated? Moles will be calculated by the formula, that is weight in gram divided by molecular weight. Then millimoles will be find out here by the formula, that is weight in milligram divided by molecular weight. Now normality is a second term of your expressing concentration of your solution. Now normality is defined as a number of equivalents of solute that will be divided by your number of liters of your solution containing the solute. Means a gram equivalent weight of your solute dissolved in 1 liter of solution here, that is the normality of this your solution. Now normality in shortly that will be defined here, the number of equivalents of your solute per volume in liters here. Now milli-equivalents of your solute per volume in milliliters here, that is also called as your normality here. Now what is equivalence? Say weight in gram divided by your equivalent weight, we get your number of equivalents here. Now milli-equivalents, how we get your milli-equivalents? Say milli-equivalent, that is number of milli-equivalents equal to your weight in milligram divided by your equivalent weight here. Now relation of your normality and molarity. Say molarity that will be related with your formula, that is molarity is equal to weight divided by molecular weight multiplied by volume. And then we are rearrange this equation, that is for your molecular weight becomes equal to weight upon molarity multiplied by here volume. Similarly normality, say normality that is equal to your weight divided by equivalent weight multiplied by your volume. Then what is equivalent weight? Rearrange this equation here, equivalent weight is equal to weight upon normality multiplied by volume. Then equivalent weight and molecular weight that having the relation, equivalent weight is equal to molecular weight divided by a factor H, where H is the reacting unit. In case of your acids, H plus is the reacting unit here, and for bases, OH minus is a reacting unit here. For oxidation and reduction reaction, electron is a reacting unit here. And for your ionic species, valencies. So valencies is a reactive unit here. Now equivalent weight. What is equivalent weight here? So it is defined as a part by weight of substance which is chemically equivalent to 1 part by weight of your hydrogen, or your 8 parts by weight of your oxygen, or your 35.5 parts by weight of chlorine here. Thus in finding out equivalent weight, we find out how many grams of that substance are directly or indirectly equivalent to 1 gram of your hydrogen. Now the equivalent weight depends on reaction in which it takes place here. So that will be depends on the type of reaction. Reaction decides here this equivalent weight. Now the concentration of solution that will be expressed in third way, that is your percent concentration here. Then how this percent concentration that will be expressed here? Into that here there are 3 different ways: weight by weight, volume by volume, and weight by volume. Say to that first one here, weight by weight means that is called as a weight percent. Say weight percent equal to weight of analyte divided by weight of sample multiplied by 100. Then volume percent, say volume percent equal to your volume of your analyte divided by volume of sample multiplied by your 100. And weight percentage, say weight percent that is equal to weight of analyte divided by volume of your sample multiplied by your 100. Now parts per million here is a fourth method of expressing concentration of solution here. The parts per million that will be used in order to express here, that is very minute concentration of your solution. When concentration is very less, then this concentration that will be expressed in terms of your say parts per million. That is, in short, it is called as a ppm. Then what is the parts per million? So that will be find out here by the formula, that is weight of analyte divided by weight of sample multiplied by 10 raised to 6. Means that is 1 gram of your solute per 10 liters of solution here, or 1 milligrams per liter, that is also called as 1 ppm here, or microgram per ml, that is also called as 1 ppm here. Now, method of expressing concentration, that is a fourth term. Say that is either here, say fifth term here, molal solution here, molality. Say gram molecular weight of your solute dissolved in 1000 gram of solution, say that is called as a molality. The number of moles of your solute dissolved in say 1000 gram of your solution, say that is called as a molality here. Now there is a last one, that is a formal solution here. Say this is the last method of your expressing concentration, that is a formal solution. Say gram formula weight of your solute dissolved in 1000 ml of your solution, say this is called as your formal solution. See, these are the about here, that is volumetric analysis, that is the terms involved, method of expressing your concentration. Say this is about here my topic, that is your volumetric methods of your, that is chemical analysis, that we now discuss. Thank you.